Greetings, salutations, warmest wishes, and all that good stuff. Anyway, today's video is on how to finish up the density lab. So at this time, what you should have is a data table that looks like this one. If not, you need to get it. Where we've taken the red oak block, we've found the mass, we've measured a length, a width, and a height. We've done it once using a ruler, and then we've done it a second time with a caliper. So we've got two different sets of measurements. We've got that all the way across here. We've also got some masses for some metal rods and some volumes for those rods. So anyway, we're going to use this to try and determine some densities. Now, there is one thing I need before we go any further. The purpose of this lab is to find density for all these materials. Well, one thing I need to figure out is what the actual density was for all these materials. See if I can read it from here. I've got it written up ahead. The actual density of red oak is 0.760. Let's see, the actual density of pine, 0.474. Again, these are what we're going to use for our actual or accepted values. Poplar, 0.543. And what else have we got? The next one, 0.395 for western cedars, so the least dense. Now let's take a look on down here a little bit further. Let's see what we've got for these steel copper rods. Let's see, for our steel, we've got a 7.6 actual density. Brass, it looks like we've got, I'm going to have to get up and look at it. 1 second. 8.9 for brass, 8.4 for copper, and oddly enough, I can remember aluminum. It's 2.7. I've got that one somehow wedged away in the old memory bank. All right. Now, actually, I can do a little something else up here. This is going to be 0.760, 0.474, because it'll be the same actual value that we use for every one of these. All right, so what we need to work on is getting these two values here filled in for our data table. Well, how do you find the volume? Let's go ahead and do what we call a sample calculation page. So I'm going to slide this sheet of paper back a little bit. I'm going to get another sheet of paper. At the top, I'm going to write if my marker will work. I'm going to write sample calculations down. Sample calculations. Of course, I'm going to slip over here on the edge, and I'm going to put a name and a date. Wow, I'm doing horrible with my paper management this morning. A name and date over on this corner of the paper. All right, so let's go through our sample calculations. And what we want to do is we want to show how we did every calculation. I'm going to lead off by using an equation. What is the equation for finding volume? Well, volume is equal to length times width times height. So now what I'm going to do is get out my data table and look at my first length, width, and height. So as we look at this, I've got 8.89 centimeters. I've got a width of 3.71 and a height of 1.83 centimeters. So now I've got my length, my width, and the height. And so now if I want to get this volume, all I've got to do is multiply all this together. Turn my calculator on. 8.89 times 3.71 times 1.83. And so I've got 60.3 sig figs. I can only go 3. So I'm going to have 60.4 for my sig figs out of this calculator. So my volume is 60.4. And now, whoops, you didn't see that. 60.4. Now, I also need to finish that on the data table. 60.4 centimeters cubed. Be sure to write your unit down on that table that we've got. So there's what my sample calculation table looks like right now, or page. My data table, I've now got this number. Now I'm going to run down the list for every one of them. So like next, I would go do the same thing for every one of these. 8.72 times 3.7 times 1.78, 56.9, so this would be 60.0 for my next one. Anyway, you would now do length, width, and height. I'm not going to make a video watching me calculate 14 numbers. So you should be able to do the rest of these length, widths, and height. So let's finish out how to do this red oak one now. Well, the next column says, how do you find density? It says calculated density. Well, that's okay. We can do this. Density, I'm going to go back to the sample calculation page. Density, which, go ahead and note that in physics and chemistry, we use a Greek letter rho. So if you're unfamiliar with the Greek letter rho, it's kind of like a lowercase p with a little bit of a slant on the tail. Sometimes I get kind of fancy with it, and I actually put a little like this on mine. I do mine like, here's the little elementary school paper. I'll do a little loop in my tail like that. But anyway, that's all my preference. So density, the formula, rho is equal to mass over volume. So if I want to do a density calculation, I need this mass that I got in step 1. So for me, it's 48.53. So let's take this, 48.53 grams, divided by that volume that I just calculated, 60.4. So divided by 60.4 centimeters cubed. And now that's going to be equal to 0.53 divided by 60.4, 3 sig figs again. So 0.803 grams per centimeter cubed. All right, so there is my calculated density for this first one, 0.803. Now, the rest of my densities are going to be the same way. They're going to be, for each single trial, they're going to be mass divided by volume, mass divided by volume, mass divided by volume. So, for example, my next one would be the same mass. So, I've already got it in the calculator, 48.53. And this time, I'm going to take that 48.53 and divide by 60.0. So now I've got 0.809. So 0.809. Now, unfortunately for me, the answer is supposed to be 0.760. So I don't have my best answers here. But hey, that's okay. It was 10th grade. Not everything's going to work out perfect for us. All right, so we've got almost everything but this last column. Now, this last column may be something brand new to you. So this last column is what we call a percent error calculation. This is also going to be the last calculation on this piece of paper. So I'm going to go ahead and write percent error. I'm going to go ahead and write out the word so that we know exactly what this is. Percent error is equal to the experimental minus the actual value or accepted value over the accepted value times 100. So this is the equation. Now what we're looking for in this lab is less than 5%. That's normally a good accepted percent error. So what do we use for E and what do we use for A? Well, we look at our data. E is what I got. I found the density to be 0.803, and it's supposed to be 0.760. Well, let's go fill in this table. So for me, it's going to be 0.803 minus what it's supposed to be, and it's supposed to be 0.760. So minus 0.760. I know I'm not writing my units out on this one, but I thought it would kind of get in the way. Over the same accepted value, which is like the camera there, 0.760, and then whatever this is, I'm going to times by 100. Now notice how this is in absolute values. So you should never say I have a negative percent error. So I'm going to subtract the difference in the top, 0.803 minus 0.760. So my top is 0.043, and I'm going to divide that by the bottom. 0.760 is 0.5657. Well, anyway, times 100, 5 point, oh, I just barely missed it. My sig figs is still going to be 3. I wish I had a little more room to write, but anyway, I'll write my answer here. 5.66% is my percent error. So across this page, I've got, here is my volume, there is my density, and here is my percent error. And this page of your lab report should be done. You've got everything, 3 calculations. So I'm going to come over here. I got a 5.66 error on this last one. Now from here on out, I can do everything else in the calculator. The next one, I do the same. 0.809 minus 0.760 divided by 0.760 equals that times 100, 6.44. So my percent error is actually worse with the caliper. It kind of might reference that I don't know how to use the caliper as well as I should maybe. Or, first of all, these are not my numbers. So you know who you are out there. Bad. You should have done better than this. Anyway, and we can see right here, the numbers, we got a little bit of variance here. These are not, this is the closest of all of them. So anyway, you need to run through all these numbers. Now, what about when you get to this part? Do you have to show it on your sample calculations? No, because it's the same calculation. If you want density, it's just mass divided by volume. So there's mass, there's volume. So like on my first one, for steel, 24.71 divided by the volume, 3.7. So this is 6.68. Well, my actual density was supposed to be 7.6. I can do a percent error again. Subtract the difference, divide by 7.6. So 6.68 minus 7.6 divided by 7.6, negative, and I'm going to drop that negative sign, times 100. Ooh, this is terrible. 12. And by the way, if you're wondering, why didn't he keep 12.1? I only have 2 sig figs. So my answer, in reality, that should only say 6.7. My bad. Someone forgive me. I got to at least try another one of these, see if it gets any better. Let's try aluminum down here. 9.09 divided by 2.8. What's my density there? 3.2. Oh, goodness. Terrible. 3.2 minus 2.7 divided by 2.7 times 100. Very repetitive. 18.19. I'm not doing any more. That is not a good percent error. Somebody usually asks, do we need to write all our units down the table? No, you don't write your units on tables, because on the table you've already got your units wrote at the top of the column. Alright, so now how do we finish up this lab? Well, the lab report itself is going to have 3 pages. The calculations is the last page. The tables will be our second page of our report. And again, I'll do a name and date on those. So I've got the last 2 pages ready. So now the only thing left to write is the report. And I'm not going to write a full report. You can stop the video now if you know how to write a report. This is just going to be my last thing. I'm going to put my name, my date on this paper as well. I'm going to now put a title, Density Lab. Do you have to call it Density Lab? No, you call it whatever you want. But it was a Density Lab, so it kind of makes perfect sense. You're going to start off with the purpose that you've been given. Purpose, draw your line, colon. The purpose of this lab, the purpose of this lab was to determine the density of several wood blocks and metal rods. And if you didn't get that, then you can pause and replay it. That's the beautiful thing about the internet. Materials. Well, you should know what you used in lab. You know that you used either you could have used either a triple beam balance or a Harvard trip balance. But you know what you used. You used a caliper. maybe a ruler, graduated cylinder, so forth and so on. Make sure on the wood blocks you list out, like if you say wood blocks, make sure that you've got some reference over here as to the fact you had pine and poplar. And anyway, make sure you've got all this over here. If you use metal rods, you say which metal rods you use. After this part of your report, you should go to the procedures next. On your procedures, I would split it up into two parts. One for the wood, and then I would do a second part for the metal. Or you could have done regular and irregular. Either way, I would just split it up since there were two. Anytime there's two data tables, I split my procedures up to match the data tables. Then you're going to have like a steps 1, 2, 3 here, 1, 2, 3 here. Tell someone how to do the lab. After you're done writing procedures, you're going to then write your conclusions out. Your conclusion, 1, this needs to be a sentence. I want a paragraph here. This should be a paragraph. You are writing here. Don't list a bunch of stuff. Here's what I want to see. I want to see in your conclusion, I want to know, well, the purpose was to measure the density of those wood blocks and metal rods. Well, in that case, tell me. Tell me the density. Tell me what was the density of the rocks, of all the things. Tell me your percent errors. This is what, like, you might write this out. I found the density of red oak 2B. Let's use our best answer. That's 5.66. I found the density of red oak 2B. 0.803 grams per centimeter cubed. Always write your units with a percent error of 5.66%. You might then go on to say, I found the density of pine 2B with a percent error. If you can summarize it better, that's fine. But I want to know the densities. I want to know your percent errors. And I also want to know which was better. Did you get better percent errors with the ruler, or did you get better percent errors with the caliper? That's what I want to know. These are the three things I'm looking for in your conclusions. Density, percent errors, which was better, ruler or caliper. Last thing, make sure you skip a line between all these sections too. It looks bad when you don't. Source of error. Here's where you get a chance to explain. Like, for example, why did I get a 12% error? Why did I get a 19% error on aluminum? That's not good. Here's my chance to explain why did I get a 5.66 up here. So just say why. Maybe the balance you were using, you had a hard time getting it to zero because an air conditioner was blowing on it and caused it to constantly teeter-totter. Maybe your block of wood, like the Western cedar, had very rough edges, so every time you measured it, you got a little bit of a different answer every time you measured it. What if on the metal rods, you could just be honest? You had a hard time reading the bottom of the meniscus accurately and getting this volume that you were supposed to write down, like this 2.8 right here. Or it might have been the balance over here. Whatever you use for a source of error, though, the big thing is this. Why is that an error? If you said, Jimbo is my source of error, theoretically, you might could call Jimbo your source of error. But you'd have to say, why Jimbo's your source of error? Well, Jimbo was my lab partner, and whenever he measured the something with a caliper, he measured to the wrong place. I don't know. But just say why, which then caused all my volumes to be inaccurate. Do not ever say something was off. Do not ever say something was messed up or messed up. We do not say that. We're trying to look smart here, and that ain't the way to look smart. All right, so this report, when you go to turn it in, Your report's going to first consist of the report, purpose, materials, procedures, conclusion, source of error. So this is what I would end up stapling together. Let's see if I've got everything here. So my turned-in product. Ooh, name and date, every page. Name, date. Man, I almost messed up. So I would have this page. I didn't have my conclusion. I didn't have my data, my calculations. I would then take all this, staple it at a 45-degree angle in the right corner. Oh, yes, I might just check. Staple at a 45-degree angle and turn in the basket. Thank you for watching. I look forward to getting 1 million hits on this Density Lab video. Probably not. Bye.